Sure. Millions of water. Yes. So let's watch this for the next 7 minutes approx. Very interesting video.
In some ways, Australia reminds me of this glass bowl, which contains stones and a layer of plasticine or modelling clay on top. Why? I'm glad you asked. Because water is not only in the rivers and streams and lakes that you see around you, but water can also be under the ground, in layers of rock that have spaces between the solid bits. And this layer of stones represents a layer of such rock. It's called permeable rock. Allows water to flow through it, and you can see there's some water in there already. However, not all rock allows water to pass through. Some is quite solid, and the glass bowl itself represents a layer of such rock, impermeable rock, and the layer of modelling clay represents another layer of impermeable rock. Now let's imagine that it rains thousands of kilometres away in the mountains. Now the rain seeps into the permeable rock and it flows. It may take years to flow all the way, but it's filling up that space. Now nothing is happening in the centre of this dry continent. However, there's water under the ground, and if we sink a well by drilling through the impermeable rock, let's see what happens. Down we go, and look at that. We have a well and we have water coming out of it. It's called an artesian well. Now the water doesn't always spring up out of the well like that. Sometimes you have to pump it to the surface. But in any event, you can get water in dry places, even in the very centre of the dry continent of Australia, in places such as Alice Springs, sitting directly over the Amadeus Basin. But to get to that water-bearing rock, the aquifer, we need to drill through the top layer of the sandwich, about 100 metres of solid rock. Now, in order to drill through the rocks, one of these steel pipes is placed vertically and a drill bit screwed onto the end of it. It may be a large drill bit like this with cone-shaped gadgets with teeth on them. That's called a tri-cone roller bit. Let me show you how it works. Here's a smaller one. As it rotates, those toothed wheels also rotate, cutting through the rock. Now they're constantly monitoring the sort of rock they're going through. They blow air down the centre of the pipe, that pushes the rock samples up, they collect them in a little bag, test them out, and work out what sort of drill bit they need. For certain kinds of rock, they may need to actually hammer their way through. So they use a tungsten button hammer bit, and that pounds its way through as well as turning. For other kinds of rock, they may need a diamond drill bit. This drill bit actually has thousands of little industrial diamonds embedded in the cutting face, and that's very efficient for cutting its way through hard rock. The layers of permeable rock which contain water may be hundreds or even thousands of metres below the surface of the Earth. So the drills need to be lengthened as they go down. At regular intervals, new sections of pipe or shaft are attached at the top. Each section is screwed and welded into position. So the drill is now pushing down through the impermeable layer into the permeable layer of rock which contains water. These are cores of rock which have been brought up from below. The holes and cracks in these samples show that the rock layers in this region contain water.
There's the red mud rock, and we can see a few worm burrows there where little worm burrows have burrowed through the sand and the seashore. The water's held in the sand grains. Between the sand grains.
What's to see, this is the different colours we're going through here.
Yeah, that's where the iron stone has come out of the mud rock and stained the white rock.
Now the next problem is to get water up out of the bore. There are several ways of doing this. One is to use a submersible bore pump, which consists of an electric motor right down the bottom drives a shaft which turns a series of propellers which push the water upwards. Water is actually sucked in through here. And that whole area is protected by this, a screen, which is a large cylinder with slots in the side. So it acts as a filter to keep rock fragments out of the bore. It's made of stainless steel and it's worth over $1,000. But it's a very important part of the bore because not only does it keep the water clean, but also it protects the pump from damage. Next, the bore pump is raised vertically and lowered carefully to the bottom of the bore. As it goes down, extra sections of pipe or bore casing are attached to it so that when the motor reaches the bottom, there's a continuous pipe coming all the way to the top. This is a completed bore head. That's the bore hole down there. Water comes up and through what's called the telephone. I think you can see why. It's shaped a little bit like a telephone receiver. And then down that pipe there and away to a storage tank. Now, when the water comes up from the bore, there's air mixed with it. So there's an air valve to let the air escape. So when I switch it on in a moment, you'll hear a great rushing sound as the air comes out of the valve. It's off at the moment, but it's time to switch it on. The air's gone now, so water's flowing through the large pipe. Let's just check that out with the test tap. No doubt about it. From 17 bores around Alice Springs, water goes to 4 large concrete storage tanks, which together hold 90 million litres. From these storage tanks, water goes through a series of pumps, booster pumps, into the town water supply. And so we have the amazing situation in which a town of 20,000 people, Alice Springs, in the centre of outback Australia, has a plentiful supply of pure, clean water with no restrictions whatsoever. Isn't science wonderful?
Isn't science wonderful? क्या समझ में आया? I think this is a very good explanation for the artesian well. वही हम अगर बुक में देखें, saying the same thing, but in a much complicated way. तुम्हें ये भी पता चल गया हो कि तुम्हारे घर में पानी कैसे आता है if you have a submersible. Let's see where we are. Yeah, here. So this represents an artesian well. This is what he showed as the glass, the glass of the ball, impervious rock. Then on the top layer you have the clay, which is again impervious. The rainfall is happening somewhere very far off, maybe in the mountains or thousands of kilometers away, but slowly it is recharging. These are the boulders, the rocks, and the water is filled between these rocks. When you need water, you have to drill through the top impervious rocks. Sometimes the water will come gushing out. So if you have seen the drilling for or the digging for a well, अब तो आजकल बहुत uncommon हो गया है, but previously if you will see somebody digging a well, after some point suddenly the water will start rushing up. I have a very good experience around this. My father at that time was posted in Gaya, both Gaya popularly, I hope all of you know about. So in Gaya there is this river called Falgu river. Now this river has like very shallow water, बहुत कम पानी होता है, and especially during winters when we used to go for Chhat Puja. If you know, Bihar mein Chhat Puja is very popular. So at that time, there will be no water in the river, like no water at all. It will completely look like a sand desert. Now you have to do the puja. For that, you need the water. So what people will do, you dug, like 10, 15 people will come together and they will dug their own. Like if you'll dug just for uh 3 feet, 4 feet, sometime hardly 10 feet, you will get like very good amount of water. You can create your own local pond, and this digging does not need to be done with like tools. You can dug with your hand. You dug and you will get a very good well. So water is already there, and at that place you will see water is coming gushing out. So it's stopped, and as soon as you remove the top sand here, the water will come gushing out, and very soon it will fill the hole that you have dug. This is how the artesian wells work. ठीक है, ये आया समझ में? This is understandable. So these are wells and springs we had discussed in the last class. So it's not going to be a problem. This is what we were talking about in the video, the Australia artist, the Great Artesian Basin. Although it is a big desert, but still you will find ample amount of water here. While I was looking for this video, I got another very curious video, and I want all of you to watch that as well. So let's watch this for another few minutes.
Central Australia is legendary for its dryness, but there is water here, and the people who live here, the Warlpiri, need to know how to find it. So they use all the tracking and signs in the book. For example, there's certain birds that are a giveaway. Corellas, those white cockatoos, are never very far from free water. Budgerigars, the same. Pigeons are a good indicator that free water is near. So you go hunting and you could find a creek with like a waterhole where the birds are drinking. But often the creek looks like this, and it's not too promising if you're thirsty. Still, you can then look for other signs. Often you'll find where cattle or other animals, roos for example, have been scratching away in the creek bed. And that's a good indicator because they know where to find the water too. At other times, you find the lowest point and test it for yourself. Well, let's clear all this dry sand away. Now I'm using a spade, but for the traditional people, this is more the sort of thing you'd use. One of these, it's a very good shovel, and you can see already, despite the dryness of the surface, I'm getting down to damp sand. There's at least moisture there. Let's get cracking. Now this is strikingly warm work, and you wouldn't want to get it too wrong. Fortunately, it looks as if we haven't, because that sand is now coming up not moist, but really soggy. It almost squishes. So there's free water down there if I can get a bit lower. I'm almost down to the level of my arm. And you can hear it now starting to splish if I stir it up. And indeed, if you look into it, you can now see the water that's soaking into that hole. Now that would save your life. You could drink that and survive, but it's pretty murky. It would be nice to get it cleaner if you just want to drink. So we'll leave that filling up for a bit and make one other bit of equipment. You might have it with you in the form of a cup. If not, cut something like a plastic flask down. Here goes. I just want a little baler. Work my way around there. and cut the bottom off to make a small baling bucket. Not pretty, but serviceable. Now the trick is this. I've stirred all that water up to make it dirty, and as I press the sides, more stuff flumps into it. But if I can slowly extract the dirty water, it'll be replaced by clean water flowing in sideways through the sand, and that will be filtered. So if I go carefully and don't muck the hole about, I should be able to slowly bail the dirty water out. It will get gradually cleaner and cleaner. Well, let's see how it starts. That's the unpromising sort of dilute mud we're beginning with. Let's just keep bailing and see how it turns out. That's probably about halfway. It's not wonderful yet, but at least it's cleaner than it was. I'll give it a few more scoops. And that's about as good as I'll get this particular hole, I think. And it's not pure, it's not perfect, but after a digging stint like that, it's very welcome.
It's a very good show actually on YouTube. If you are bored of watching reels, you can watch Curiosity Show. Something similar used to come on Indian television long back when we were kids. Man versus Wild, and this is like very, very different. Man versus Wild is fictionalization of the events, making it more interesting. And in that sense, this is based upon science, like how science works. So you will find many explanations of various topics about how the science works. Purely science, nothing, no dramatization at all. So anyway, कहाँ था मैं? So partition well we have covered, and I think with this we have completed this chapter. We can move to the next chapter, which is landforms made by running water. Babu is saying destroy in second. I don't know how old all of you are. Long back when we were kids, there used to be a program on DD1, Tarang. Hindi में आता था तरंग. NCRT लेकर आए तरंग. NCRT used to create that program. It used to be very informative, like a lot of science stuff that I've learned from that. So देखा है किसी ने? नहीं. DD1 देखने वाले कम लोग हैं. हमारे केबल नहीं था. देखा है. Good. So we used to wait like for that so very eagerly and patiently. Especially on Sundays, it used to come around 10, if I'm not wrong. So the next chapter is landforms made by running water. So in the previous classes, we have read about erosion and weathering, so I'm not discussing those again. There are a few terms that we should know. I hope you're aware of, but yet again, the catchment areas of the rivers are the areas from which the river is getting all its water. So this area, when the rainfall will happen, all the area where the rainwaters will somehow run off to the river will be called as the catchment area of that river. And this area, as we can understand, will be marked by the mountains, the uplands or the highlands, mountains. So the cliffs of these mountains will, so whatever rainfall will be happening on this side of this mountain will come to this river, and whatever rainfall will happen to the other side will go to some other river or some other river basin. So this mountain cliff is known as watershed. The crust of the mountains is the divide or the watershed from which streams flow down the slope on the both side to begin their journey to the oceans. So the crust is deep slope, watershed. Now, some rivers are called as consequent streams or consequent rivers. Consequent river क्या होता है? The initial stream that exists as a consequence of the slope is called consequent stream. Consequence के चलते आया consequent. The rivers which are formed because of the slope. Initially, from Himalayas, there was this gradual slope from Himalayas to the Bay of Bengal. So Ganga River will follow this slope, and that's why it will be called as a consequent river. Sometime it may happen that river will not follow the gradual slope, but it will cut down the uh, the layer within and creates its own course. Here we are discussing about consequent streams which are formed because of the slope. Now, once this main slope is formed, other rivers or water streams will start joining this, where they will be called as insequent streams. This will depend upon the rock structure, the bed of the surface, the rock on which this river is traveling. So if the rock or the bed is made up of homogeneous rock, that means the rock everywhere in this region is almost kind of the same. So the weathering and the erosion by the river will be same. It will not follow any particular line. Wherever the slope will be, the river will follow that course. But opposite to that, if the bedrock is made up of harder and softer rocks, in this case, if water will start flowing from here, let's suppose, it's coming here, it will find a hard rock, cannot erode it. So it will erode the softer rock and take this course. Again, here it will find a softer rock, so it will take this course and will move like this. So in this case, you will find that the water streams, the insequent streams, are not following the slope, but they are following this pattern of hard and soft rocks. Wherever they are finding it easier for them to cut through, they will follow that path. And they will be forming this trailized or rectangular shape of drainage pattern. First वाले में क्या बनेगा? This will form a dendritic drainage. Dendritic means tree-like. So here you can see where there is homogeneous bedrock, it will create a dendritic kind of tree-like structure of insequent streams or tributaries of the main river. So this generally you will see in northern India. This kind of pattern you will generally see in southern India. Now, the next topic is the mechanism of humid erosion. In the last class itself, we have read about mass movements, we have read about lubricating action of water, we have read about soil creep, and we have also read about landslides. So this topic is covered. Next is the process of river action. This is important. This whole part is important. Pay a little attention. You can draw this diagram. It's a very useful diagram. इसको एक बार draw कर लो या कर लेना. Like try to learn how to draw this diagram. This will come very handy in exams. पहले थोड़ा सा explain कर देता हूँ मैं, then draw it. River erosion and transportation. So there are four ways in which a river can erode or transport the materials. Four ways can बहुत closely, they're very similar to each other and can create confusion in prelims specifically. So the first one is aberration, the second one is corrosion or solution, the third one is hydraulic action, and fourth one is attrition. बहुत ध्यान से सुनना, it's very very tricky. देखो, corrosion or aberration is mechanical grinding. It is mechanical grinding of the reverse traction load against the bank and the bed of the river. Water will be carrying some load with it. Load means it will be carrying some rocks, sediments, debris. Here you can see it will have dissolved minerals, suspended particles, it will have pebbles, stones, rocks, boulders, etc. So when these traction load will do the mechanical grinding against the banks and the bed of the river, they will collide with the banks and the bed of the river. They will break down into parts, and this process is called corrosion or aberration. This can be of two types: lateral corrosion and vertical corrosion. Lateral corrosion, when the river when these loads will be colliding with the horizontal or the banks of the river, they will create this lateral or sideways erosion. But when they will be colliding with the bed of the river, they will be doing this downward action that deepens the river channel. Lateral में widen होगा, vertical में it will deepen the river channel. Now this was easy. Corrosion or solution. Corrosion is chemical or solvent action of water. यहाँ पे क्या होगा? The water will dissolve some of the soluble rocks like limestones. So when a river is flowing, if some rocks like limestone or it's passing over a structure which is made up of limestone, as in this case, when the river is passing, and let's suppose here is a stone or the rock structure made up of limestone, the river will easily dissolve this and make a path for itself. So corrosion is chemical action. इतना याद रखना है. Corrosion is chemical action, aberration is or corrosion is mechanical grinding. वो दोनों तो आसान था समझना. नाउ हाइड्रोलिक एक्शन में क्या है, वी समटाइम टेंड टू थिंक कि all this grinding by the water and the load is the same thing, but the mechanical loosening or sweeping away of the materials by the river water itself. First case में aberration में क्या हो रहा था, that the load of the water was acting on the banks and the river bed. But in the case of hydraulic action, the water itself will do the erosion. So water will splash against the river banks. It will go into the cracks of the rock and then it will disintegrate the rock. This is known as hydraulic action. Okay? So generally we do not differentiate between the two. लेकिन ध्यान रखना है. Corrosion is not the action, corrosion is or abrasion is not the action of water on the rock. It's the action of the loads which are suspended into the water on the banks or on the bed of the river. Now, attrition is the wear and tear of the transported materials themselves. Again, very interesting and complicated. These rocks, these loads which are there into the water, they will be colliding with each other. This will lead to their own wear and tear, and that is known as attrition. This will lead to the formation of smooth, rounded form of pebbles. ठीक है, समझ में आया चारों टाइप? Clear now? Abrasion, corrosion, hydraulic action, and attrition. All these four things are happening in the water or above. Clear है ना? It's clear to all? Second one is easier. Second one में तो कुछ ऐसा नहीं है ना. Second one is just chemical. So water is passing through some rock structure, and if it is soluble, if the rock is soluble into the water, like limestone क्या होता है? It's very soluble. So it will dissolve that part and create a path for itself. Fourth one is when these loads, the pebbles, the boulders, the rocks which are suspended into the water. In the first case, they were attacking the banks and the river bed. तो उसको aberration कह रहे थे. In the second case, they are colliding with each other in the water when they are suspended. They are floating from here and there, then colliding with each other, and that will lead to the smooth, round-shaped stones. ठीक है? बाबू, is it clear? बाबू, जिसे पूछा उसको तो क्लियर नहीं हो रहा है. If it's not clear, I will explain again. Next, the course of a river. See, this we have discussed probably during NCERT classes as well. Thoda, we will be discussing in a little detail here. So, the river passes through three courses: the upper course, the middle course, and the lower course. In the upper course, you can draw this. In the upper course, it will be forming the structures like gorges, rapids, waterfalls, and river capture. In the middle course, it will be forming interlocking spurs, meanders, and river cliffs. In the lower course, it will be forming floodplains, oxbow lake, and deltas. So the upper course is when it is starting from the mountains. Gradually, it will come into the plains, gentle, where it will find gentle slope. Finally, it will come to the lower course where the slope will be very, very less. And the slope decides the upper or middle or lower course of the river. Here, when it is in the upper course, the vertical corrosion will be very high. Vertical corrosion is very high. When it is in the middle course, it will start eroding the sides of the river, and it will create like the river will get very wide. So here you will get, in the first case, you will get steep gorge like V-shaped valleys. It's a V-shaped valley. Here you will get open, widening, gentle slope valleys. The valley are of gentle slope, open and wide. Then in the third case, you will find alluvial depositions. They are very gentle sloping, smooth and very wide valleys. Now we will discuss each of these features in detail. Who can you draw? Look, you have drawn this. पढ़ना का तो हो गया, चलो. Those who have not drawn, check the book and draw it. Leave the space for now. Now in the upper or the mountain course of the river, as we discussed, the vertical corrosion will be high. The slope is very high. This will lead to the creation of distinctly V-shaped valleys. The downcutting takes place so rapidly that the lateral corrosion cannot take place. I have to show you one more video. Wait, let me see if I can show you that video. Just give me a second. गलती से टैब बंद कर दिया मैंने.
In some ways, Australia reminds.
It's a good indicator because they know where to find the water too. At other times, you find the lowest point.
Water holes in creek.
So this is a very quick video.
Waterholes and creek beds are pretty dicey affairs. They dry out and they get very shallow. So what's the deepest waterhole in Australia? The deepest Australian waterhole? Well, that's an unfair question. Mount Gambier Lake's very deep, and so are Piccaninny Ponds and a host of others. But a waterhole is traditionally in the bed of a river, the part that doesn't dry up. And interestingly enough, this is probably the deepest in inland Australia. Doesn't look much, the river's very narrow, but it's very deep. It's Cooper Creek, a place called Kalyamurra Waterhole, about 20 kilometres away from Inaminka. This is what happens. The Cooper floods, and when it does, it brings down an enormous quantity of water. That's normally enough to tear the sand off the banks and the river runs wide. But just here the banks are made of rock on either side. The river can't tear those apart, it has to squeeze through the middle. So it runs narrow and extremely fast. So fast that it tears the bottom out of the river on the other side and makes a great waterhole which has been measured at 30 metres. And that makes it the deepest waterhole in inland Australia.
I put so much. What it's basically saying in Australia, when this river, sorry, what this river is doing is when the Cooper River floods, it releases a stream amount of water. In normal cases, this could have been led to flooding. Water could have gone far out of it, it would have blown away the sand around it. But when it passes through this specific region where the sides are made up of very hard rocks, what it does, it cannot erode this hard rocks. So instead, because this large amount of water is gushing through this very narrow band at a very small time, it starts eroding it vertically downward. And this, as you saw in the video, it's a very narrow passage, but it's about 30 meters deep, and it makes it one of the deepest water hole. These regions are known as water hole. So even when the entire river will dry, this region will still have some water. स्क्रीन शेयर नहीं हुआ था क्या? स्क्रीन शेयर हो गया था ना? Screen was shared while I was doing the video. ठीक. Okay. So I hope you understand what is vertical erosion. Now, so this will lead to the formation of gauzes. There are many gauzes in Indus gauze in Kashmir. They will have very steep sides. The Grand Canyons in USA are also some of the examples of these kind of gauzes. Next one is river capture. So this is very interesting, although easy to understand. There are two rivers. Stream A, this is the main river, the stream A. This is stream B. There are two rivers going. And this is a subsidiary stream for river A. This is a subsidiary stream for river B. What this river A is doing because of certain erosion and all, this stream will go on and start cutting back. Different rate of cutting back, headward erosion. So ultimately this will reach up to this point and it will cut off the water from going in this area, and this water will start coming to this river. So that's why it is called river capture or piracy of a river. Piracy or river beheading. बहुत interesting names है. Its development is dependent on the different rate of back cutting into a divide. For instance, if one side of the divide is of greater gradient or receives more precipitation than the other. So when which will be cutting which river, it depends upon which has faster rate of cutting. If this gradient is higher, steeper, so this here the erosion will be faster, the cutting back will be faster. Or if rainfall is heavy rainfall is happening on this side, again the erosion will be higher and it will merge with this stream and cut that stream. So its greater erosive power will succeed in enlarging its basin at the expense of the weaker stream. The stream A may eventually break through the divide and capture or pirate stream B. Wherever this will happen, it will be called an elbow capture. Here it is bending like an elbow. It is known as the elbow capture. Some examples are given here, not very important to memorize. So let's move ahead. The next point is the rapids, cataracts, and waterfalls. So one thing to remember here is that rapids, waterfalls are the phenomena of youth stage. You will not find waterfalls into the middle stages of the river. सबसे पहले rapids, what's happening? There is unequal resistance of hard and soft rocks. See, as the water is flowing from here, at some places the water will the rock will offer more resistance. So water will be traveling at a lower speed. When this rock is erodible, soluble, soft rock से जब गुजरेगा, so because it is acting on the softer rock, it will be slower. But as it will passing through the harder rock, there is nothing to corrode. So like it will act as क्या बोलते हैं उसको हम पार्क में जो स्लाइड्स लगा होता है. So it will act as a slide for the water, and the water will quickly slide through these harder rocks. So the speed of water will increase. If you will ever go to canoeing, river rafting, you will feel you will face such situations. Suddenly the speed of the water will increase at certain places. कोई गया है और राफ्टर वगैरह राफ्टिंग किया है ना? Vamsi, what again? Sorry, what you are asking for explaining again? हो गया ना? अभी आया समझ में या should explain it again? It's easy. It's not nothing. See, two rivers are flowing like this. Now, at this place, this is the water divide. We read about water divide. So this is the crust of the mountain. Whatever water is going to this side is going to this side. Whatever water or rainfall is coming to this side is coming to this side. But if the rainfall is higher in this side, this river will start an erosion, a backward or headward erosion. So it will slowly erode this area and it will merge with this stream of water. And now the water will start coming from this direction to this river. Instead of going to this river, it will behead this river. It will pirate a source of water for this river. So this river will become weaker and the more water will start to come into river A. ठीक है? Okay. This is clear for all. What is a rapid? When these rapids are of larger dimensions, they are called cataracts. The phenomena is almost similar, but just the size is higher, not greater. Next is waterfall. So, in rapids, the height is very less. The height or the quickening of this water will not be for long. It will be for a very brief period. But in waterfalls, the river plunges down a sudden fall of some height. They are called waterfalls. So definition you can write if you want. When the river plunges into a sudden fall of some height, they are called waterfalls. Now, how they are formed? ये देख लेते हैं. So the first way in which a waterfall can be formed is when a bar of resistant rocks lies transversely across a river valley. Let's suppose this is a river, and here a bed. Here you find a resistant rock which this river is not able to erode. It is able to erode the rocks which are after this, but not this rock particularly. So what will happen? Within hundred thousands of years, it will keep on eroding. यहाँ पे देखो, because this is a harder rock, this stream of water is coming, but it's not able to erode this. But hundred thousands of years ago, this would have been also a rock structure. But because the rock was softer here, it started slow erosion. And slowly it cut through all this. Slowly ऐसा हुआ, धीरे धीरे ये form कैसे हुआ होगा? Initially it would have been like this, then like this, then like this, and ultimately it has become like this. It has eroded the whole soft rock in this, or the whole soil profile. The soft rocks have been eroded because it is falling with a high speed. It will create a plunge pool here and further erode because of the force. Next is when a fault line scrap causes a faulting lies across a river. We have read about faulting. Now, let's suppose this is the rock structure, and above this, the river is flowing. But suddenly there is a faulting, and this region goes down. So what will happen? This is the upland, and suddenly there is a faulting. So this region has come down. The river will now create a waterfall. So example of this is Victoria Falls, or on the river जिम्बेजी. याद रखना है waterfall ये विक्टोरिया किस river पे है. Such questions can also be asked in UPSC. Which waterfalls are on which river, and especially such famous waterfalls. Next one is when water plunges down the edge of a plateau. So if there is a plateau and water is falling down from the top of that plateau, it will create a waterfall. The example is Livingstone Falls. Fourth one is glacially produced hanging valleys. What's happening? First, a glacier is there. This glacier will erode the bottom of the glacier. Then a tributary stream reach the main U-shaped valley below as a waterfall. When this glacier is uh, melted, this will leave a U-shaped valley here. मेल्ट कर गया, नीचे यू शेप्ड वैली बच गया. Some stream, some tributary stream of this river will come here and start falling into this. This will also create a glacier. You can do a Google search. एक बार search करो Yosemite Fall. Let me show you this. It will be much more clearer. Wait. कॉपी हो रहा है क्या? See, this is an Yosemite. It's a glacial fall. इससे बड़े नहीं आ रहा है. यहीं पे ये कलरफुल इमेज बनता है बिकॉज ऑफ सन रेज. बस इतना याद रखना है, हैंगिंग वैलीज बनेगा बिकॉज ऑफ ग्लेशियल एक्शन. ज्यादा डीप में जाने की जरूरत नहीं है. कमिंग टू द नेक्स्ट पार्ट ऑफ इट विच इज मिडिल और द वैली कोर्स. हियर what kind of structures we were looking at? Interlocking spurs, meanders and river cliffs. So let us first try to understand meanders. यहाँ पे बहुत अच्छे से meandering को explain किया है. Meandering simply means the swing of as the water flowing under the gravity seldom flows straight. Water does not flow straight in a straight line. What it does, it meanders, it bends left and right. So the irregularities of the ground force forces the river to swing in loops. What it does, it swings in loops, forming meanders, a term derived from winding river. मेंड्रियाज इन एशिया माइनर, ये एक रिवर है मेंड्रिस, इसी से इसका नाम ड्राइव हुआ है मेंडरिंग. So how does it work? It's a very important diagram to understand meandering. A little complicated, but yet easy. See what's happening here. First, water is coming into this direction. So what it is doing, that it is eroding because of the force, it is eroding the soil on this part, this band. While it is doing this, there is vertically, imagine this line, this water as a vertical water going down, because this stream which is going and hitting this front, it has nowhere to go. So what will happen? So this water which is going like this and hitting a wall, it will plunge like this, right? नीचे जाएगा, but it is also moving forward. So ultimately it will have a screw-like action. It will have a screw-like action. This will be going like this and bending like this and going deeper as our screwdriver moves, or our as we push a screw. How does it move? It will be going deeper. So it moves a little forward and moves deeper. This is the action of the water in the vertical direction. You can imagine it like this. यहाँ पे vertical में देखो, this water is coming like this and it moving like this. So what it will do? It will deposit the water on this side. So on one side it will be eroding, on the other side it will be depositing. This side is, इसको क्या बोलेंगे, concave या convex? कौन सा साइड है वो रिवर का, concave साइड और convex साइड? Badhi. In physics classes, I have probably taught you how to identify, how not to make mistake with convex, concave and convex. बताया था मैंने? Concave is a cave. सिंपल याद रखना है, concave is a concave. Cave वर्ड से concave बना है ना? Wherever there is a cave, it's concave. उल्टा हो गया तो convex. So here you are seeing the formation of a cave, and it's a concave side of the river. So on the concave side, you will always find that there is erosion happening. ठीक है? So on the concave side, there will be erosion, and on the convex side, there will be deposition. Here also now this becomes the concave side. So erosion here, deposition here, erosion here, deposition here. So this pattern will continue. This will lead to the meandering of the river water. Now there is also an associated phenomena which happens in the later stage of the river, which is called oxbow lake. Now if you can understand the meandering, understanding oxbow lakes become very easy. What's happening here? The water is coming like this, eroding here, depositing the water, depositing the soil here. Then this process is continued. This is coming here, depositing the soil here. Now changing the direction, going here, moving in this direction. After some time, if there is extreme sedimentation, suppose this process continues for years. Here the sedimentation will keep on increasing. Here the sedimentation will keep on increasing. Some year, if the water comes with extreme sedimentation, this whole region will be filled with the sediments. This stream of water will be left out, and the water will start flowing in a relatively straighter fashion. And this region will be left as a oxbow lake. It will have no connection now with the river. This happens in the later stage. अभी उसके बाद में आते हैं. But I hope if you understand this phenomena of meandering. Now here the rivers will create river cliffs and slip-off slopes. As you can understand, here the deposition is happening, so it will be creating a slip-off slope. You might have seen rivers. Rivers generally create two kinds of structure. On one side, it will be a gentle slope, so you can gradually go into the river. You will not drown, and this creates very good bath places where you can bath in the river or ceremonial activities, etc. But on the other side, it will create a cliff. So these are the very dangerous places to take bath in. Only the experts can dare. Otherwise, you can quickly drown in these rivers. So इसलिए ये बनाएगा एक साइड रिवर क्लिफ, दूसरे साइड स्लिप ऑफ. ठीक है. This is clear. Slip off and river cliff. Where the deposition is happening, it will create a slip off. Where the erosion is happening, it will create a river cliff. This is the concave bank and this is the convex bank. This is concave bank and this is the concave bank. This is shallow and this is deep. You can draw this one also. Now next is interlocking spurs. Interlocking spurs is simply what's happening. You might have seen some pictures of, अच्छा यहाँ पे है शायद, there is a picture. So you have seen such image where a mountain or a valley will be in such a shape that it feels like a क्या बोले उसको, interlocking of a chain. It's not a very important feature, but if you are mentioning, just mention it there in the key. This, if some such question arises, key in which part of the river you can find interlocking spurs, you should know. So as the streams flow on, the meanders migrate progressively outwards, with the interlocking spurs alternating with undercut slopes. As the meandering will be happening, it will be cutting first in this direction, then it will cutting in this direction, cutting in this direction, and that's how it will be changing its course and will create this interlocking spurs. Right. Now, one thing which need to be understood here, that meanders are a feature, a prominent feature of the later stage. In the early stage of a river, meanders have just started to form. It's the beginning of the meander. In the middle course are the only beginning of the downstream swing. Here the bends are restricted by the interlocking spurs. In the middle course, you will not find big meander. They will be limited by this interlocking spurs. Full meanders will only develop in the later stage. Yes, this is Babu, this is formed because of the same process, same erosion and deposition. But this will restrict meandering and it will not allow the creation of features like oxbow lakes here. These mountains chains will not allow structures like that. It will only create small meanders. The process is same. The reason for the formation is same. Next is lower or plain course in the later stages. यहाँ पे क्या होगा? Lateral corrosion is now very strong. The vertical corrosion is less. It will lead to the creation of flood plains, and in the later stage, it will create braided streams. Braided stream means the water will now start to divide into various streams. ठीक है? Instead of flowing straight, it will get divided. यहाँ पे लिख लो, देख लो. The large sheets of materials are deposited on the level plane and may split the river into several complicated channels so that it can be described as a braided stream. So features here are some. First one is floodplain. easy to understand. This is a good diagram also. So this is the river. This is the leaf. Leaf is when the river forms flows normally, its bed is raised through the accumulation of deposits and materials is also dropped on the sides, forming raised banks. Normally, when the river is flowing, it generally erode the sides, and that's how these embankments are formed. So natural embankments or raised banks are called leaves. On these natural embankments, sometimes we create artificial embankments to increase the height to stop flooding. And then there are plains. Some examples are given here. Some of these rivers are important. If you just want to do some Google search, do the Google search. Otherwise, you don't need to remember them exactly. I hope all of you know that Huanghe River is the sorrow of China or Chinese sorrow. Which river is known as the sorrow of West Bengal? बताओ जल्दी। वैदही का आज सारा गलत हो रहा है तुक्का क्या हो रहा है वैदही। दामोदर इज नोन एज दी। मैं तो बता नहीं रहा था आई थॉट ऑल ऑफ यू नो। तो दामोदर इज द sorrow of West Bengal. Uh, sorrow of Bihar. सिमरन पहले से टाइप करके रखी थी कि सर अब पूछने वाले हैं। अब नॉट इट फिनिश द क्वेश्चन। ठीक है। गुड। ऑक्सबो लेक्स आई हैव ऑलरेडी एक्सप्लेन दिस कैसे बनता है। So these are the cutoffs or biots in the Mississippi Basin, not specifically in the Mississippi Basin. It can be formed anywhere. Even in India, we see many oxbow lakes formed by prominent rivers. The last one is delta. In the NCRT classes, I've explained in very detail about delta. In environment classes also, I think I've explained very detail about estuarian land, जो landform ने पढ़ाया है. There I've explained in detail the difference between delta and estuaries. याद है सबको? So those who have not joined that batch now, what I can do instead of like redoing that, I will send or not, I will not send. I will send and I will miss. Vamsi is in the class. Yes. So Vamsi will send that video link into the personal mentorship group, and then I will forward it into the geography WhatsApp group for the new students. So I think that's a very detailed and deep analysis. You will not find anything like that at one place. The whole difference between delta estuaries, how their landforms, the life structure, etc., differs. Otherwise, it's easy to understand delta as the river is now coming with a lot of load, silts. It will start depositing it here and will lead to the formation of delta. Because it is in the shape of a delta or a triangle, it's called delta. There are some conditions which are required for the formation of delta. First one is of obviously very true that there should be very extensive sediments. If river is not carrying sediments, it will not make delta. Like river Narmada, it's not carrying sediments that much because it's flowing through a valley, rift valley, hard mountains. So will not create estuaries. Sorry, it will not create delta. The coast should be sheltered, preferably tideless. If there are continuous tides coming, what it will do? It will erode the silts, or the ocean will take the silts with it. So it should be sheltered or tideless. The sea adjoining the deltas should be shallow, or else the load will disappear in the deep waters. As you will see in that explanation, as the water is coming down, there should not be a rapid decline. ऐसा रिवर आ रहा है और अचानक से there is a rapid decline, so road will disappear into the ocean. There should be a gentle slope which gives the time for this to form, and that's why you will see that on the eastern side almost all the rivers are forming deltas, because this slope is very gentle. On the other hand, this slope is very steep. So you'll not find many deltas on this side of India, but you'll find many deltas on this side. The next one is there should be no large lakes in the river course to filter off the sediments. If the river is coming and in the middle there is a large lake, so what will happen? The water will start depositing in the sediments will start depositing in that lake, and by the time the river will come to the ocean, it will have very less sediments. Strong currents, there should be no strong currents running at right angles to the river mouth, washing away the sediments. If you have gone through the NCERT classes, you will probably remember what happens at the Peruvian coast, that there is this rightward movement of the air, and because of that, there is this phenomena of upwelling and downwelling. If something like this is happening, if the ocean is flowing in one direction at a very high speed, again, this will blow off the sediments and lead to not formation of or non-formation of delta. River rejuvenation is not a very important topic. The simple idea here is that sometimes rivers become young again. How they can become young? There are two ways which are described here. First one is that either the sea level goes down. When the sea level goes down, it will give an extra force for the river water, and the river water will start flowing at a higher speed. As it will be flowing at a higher speed, it will start higher erosion. So at the point from where the erosion will start is known as nick point. Simple है. The other way around can be that because of some tectonic movements, the positive movement happens and there is a rise in the sea level. अच्छा, इसमें एक और था. First is either there is a decline in the ocean level, or there is an increase in the height of the river. In that case also, the speed will increase. In some cases, there is a rise in the sea level, which is more common nowadays because of the global warming and all. The level of the sea level can rise. This will draw the valleys and weaken the erosive power of the river. उल्टा काम करेगा ये. The lower course will be submerged into the ocean. Human aspects of the river में कुछ खास नहीं है. Some rivers are used extensively for transportation. I think we have discussed about this in some classes. China depends heavily on the transportation through these rivers. Even in Brazil, these are very important source of transportation for the people. People also create artificial harbors by dredging. Sometimes you have to, dredging is removing the sediments from the ocean, the river bed. So निकाल के artificial harbors create कर सकते हैं. They can also be used for the formation of hydroelectricity power, etc. ये सब पता है अपने को. So let that be fishing, political boundaries, supply of water, etc. So that's the end of this chapter. We will do some answer writing in the next class on these topics. We can go through the exercise once. Next chapter is the land formation of glaciation. Not a very important topic, although very complicated, too many things to memorize. But we will limit ourselves while going through this chapter. जितने काम का है उतना पढ़ेंगे. Such questions are not asked in such detail. So देखेंगे जो अपने काम का है. Next chapter after that is important. The arid or desert landforms. तो इसको आके इन दोनों चैप्टर्स को कल we will try to finish. ठीक है. Could we end today? Any questions, anyone? I was not healthy as such. टफ लग रही है ज्योग्राफी. नहीं 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 टफ. टफ क्यों है? लाइक एनसीईआरटी क्लासेस में टफ. यहाँ क्या टफ लग रहा है सच? लाइक I think these are like more easy. Yeah, if I'm making any mistake, I'm assuming that these are easier. So I'm moving at a brisk speed. बहुत ज्यादा कंटेंट तो नहीं है इधर. Is it a common feeling or? So don't try to imagine, no, just try to Google the landforms. Like whatever you are looking at, Google it, see it from your own eyes. It's better. Now we live in a tech-friendly era. You don't have to imagine. You can just see it. कि अच्छा ऐसा बनता है क्या? चलो, bye. Anything else? Anyone? हाँ, Shankar is asking a question. Sorry. Shankar is asking hydraulic action. Hydraulic action क्या है, Shankar? It's easy. Just water is acting on the film. What happens? You might have seen hydraulic drill. देखा है hydraulic drill? by the force of the water, you are trying to break something. So the water is coming with a high speed. It's going into the cracks of the river, of the rocks, and breaking it because of the force of the water. Simple. It's not very complicated. It's as I think you're trying to find something very important here, and that's why you're confused. It's not that important. It's very simple. The only thing that we have to understand is कि different constituents of river are acting differently. So the rocks are acting differently. The rocks are acting on the river bed and they're acting on the banks. The water is acting differently on the river bed and the bank. The water is also acting in a chemical way, so dissolving the rocks, so that's different. And the rocks which are suspended into the water, they're acting on each other, so that's also different. And that's the different names. That I think is easily understandable. Because you're thinking too much, ये कुछ तो बहुत important इसमें है, मुझे मिल क्यों नहीं रहा है? I think that's why it's creating more confusion. ठीक है? चलो. I was in mood of giving some philosophy today, but in the newspaper class, let it keep for that. Let us keep for that philosophy in the newspaper class. Bye.